Hello dear children, in the previous class of sound chapter, we covered unit A and unit B. Children, in a unit A, we covered the terms related to the sound and the terms related to the wave, and there only we discussed about the echo and its application. Whereas in a unit B, children, we discussed about the types of vibrations. There we covered about natural vibrations, damped vibrations, forced vibrations, and finally we discussed about the resonance and its applications. And also we discussed the numericals based on unit A also. So the previous classes links will be given in the description. Just kindly go through it so that you will get a command on the previous concepts. Children, especially then today what are we going to discuss? Children, today we are going to cover the concepts of unit C. So in this, children, especially we are going to talk about the characteristics of the sound. So that is our main agenda today. Okay, na? So under this characteristics of sound, children, we will be discussing about the loudness, and then we talk about the pitch, then finally we talk about the quality. Children, so these are the three characteristics of the sound. So first of all, children, why do we need to learn about these characteristics of the sounds? Children, we know that different musical instruments will produce sounds with a different notes here. Then how they are distinguished? So based on loudness, based on pitch, based on quality only, we can distinguish the sounds produced by the different musical instruments. So first we discuss what is the loudness and how is it related to the intensity of a sound, which we discuss. Children, so what is the loudness? For suppose the two sounds are produced which have same pitch and same quality. Then how they are distinguished? They are distinguished by using a property, by using a characteristic called actually loudness. So loudness is a characteristic of a sound by virtue of which loud sound can be distinguished from a faint one if the both sound waves have same pitch and a quality. And children, here loudness of a sound is measured in phone. So here phone is the unit of loudness. Then what about intensity? Children, intensity is not a complete, what we can say, is only related to the sound. So intensity actually related to the energy. Then you may get one doubt, sir, as it is related to the energy, why are we discussing in today's class? But don't you think that sound is energy, children? Yes, so sound is one of the forms of energy. So it's very important to us to learn what actually intensity. For suppose, children, some energy is flowing, whatever it may be. Now I am not talking about the sound, any energy, it might be light energy, heat energy, okay na? So sound energy also. For suppose, so here some sound energy is flowing, let us say like this. So here is how some energy is flowing. Let us think, sir, energy is flowing. So as the energy is flowing, children, so perpendicular to this energy, just imagine a surface. Okay, then obviously what will happen? This energy will pass through this surface, how? Perpendicularly, normal to the surface. Okay, na? Fine. So we are going to take the surface, and here it is a 1 meter length, let's say width, and 1 meter height, which means what is a unit area? It is a unit area. Actually, it's very, very important. So this energy is passing through this unit area normal to its surface, and we need to calculate how much amount of energy is flowing through this unit, what we can say normal area, in 1 second. In 1 second. So the amount of energy which is passing through the what we can say unit normal area in 1 second only, we can call it as intensity. So let us write first of all. So here intensity, how can we calculate here? Intensity is equal to, it is energy by area into time, children. So for suppose here is a sound wave is passing, so that intensity is related to the sound. If light energy is passing, that intensity is related to the light. If heat is passing, that intensity is related to the heat. That's it. So first try to understand the concept of intensity. Is it clear? So here less the surface area, children, more will be the intensity. If more amount of energy is passing through a less area, then what will happen? That particular what we can say energy has more intensity. The best example, laser you can take, children. Why laser is so special than the normal light? Because normal light will get diverged, but whereas laser light is confined to a small area. So much of energy is confined to a small area. That's why it is a very powerful. Is it clear? So what is the intensity of energy, children? The amount of energy which is passing through the unit normal area in 1 second is called intensity. Then what are its units? Look at here. Energy is measured in joules, okay, whereas area is meter square, okay, time is second. So why I am writing like this? Because we know that joule per second is called watt. So it also can be written as watt per meter square. Children, watt per meter square is a unit of intensity. Is it clear? Fine, children. Now generally when we are having a conversion, right, conversation between with other persons, then what is the intensity of that conversion, that conversation which we will having, right? So what is the intensity of that, children? So intensity of that normal what we can say conversation between the persons, it is approximately 10 power minus 6 watt per meter square. Children, can we hear the all sounds? No, we can't hear. We only can hear the sounds from 20 hertz to 20,000 hertz. So what is the minimum sound which we can hear? We can hear with a 20 hertz frequency. Then what is the intensity of that sound which we can hear? The least sound which we can hear, children. So that is, for that the intensity will be 10 power minus 12 watt per meter square. Is it clear? So this is about intensity. But how this intensity is related to the loudness is very, very important. Children, obviously what happens, as the intensity increases, loudness also increases. As the intensity decreases, loudness also decreases. But they are not proportional to each other exactly. It won't increase or it won't decrease in a proportional manner. So there will be a certain standard relation between loudness of a sound to the intensity of a sound. Loudness to the intensity. Let us see that now. So here loudness is equal to K into log 10, here is intensity of a sound. So this is how both are related. Here the derivation how we got proved is not required for examination point of view. So they might ask you to write the relation between loudness and intensity. As it is a log of intensity, that's what I am telling you. It won't increase proportional manner. But the very important thing is that when intensity increases, loudness increases. When intensity decreases, loudness decreases. Is it clear? Fine. Now we discuss the factors affecting the loudness. Children, examination point of view, this is very, very, very important. On which factors does the loudness of a sound depends? Loudness of a sound depends. So here the first factor is it depends on amplitude. Children, it's very, very, very important. Based on this, we can expect a 1 mark numerical amplitude. So here loudness is directly proportional to the square of the amplitude, children. So for two sound waves, it can be written as L1 by L2 is equal to A1 square by it is A2 square. So this is a very, 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 very important relation. So how the question can be asked, So example, let me tell you here. For example, two waves with amplitudes are in the ratio, for example, 1:2. Then they will ask us to find the ratio of their loudness. So it's very clear, you can apply this formula. L1 by L2 is equal to 1 square by 2 square. This will be 1 by 4. Children, but don't leave the answer in the form of P by Q ratio, P by Q form actually. So it has to be written L1 is to L2 is equal to 1:4. Okay, fine. And this relation can also be expressed like this. How? A1 by A2 is equal to square root of L1 by L2. Children, based on this also we can expect the numerical. So how the numerical can be expected? Look at here. Example. So they will give you the ratio of the loudness of the two sounds. So for suppose if ratio of the loudness is given 9:25, then they will ask us to find the ratio of their amplitudes. So we know that here A1 by A2 is equal to square root of it is L1 by L2. So here you can write 9/25. So this can be 3/5. So it is A1 is to A2 is equal to 3:5, children. Okay, so this is how actually loudness depends on amplitude. So loudness is directly proportional to the square of the amplitude. Is it clear? Fine. And the second one is distance. Very important. It is the distance between source and listener. Source and listener, children. Source and listener. So it's children, it's our common experience. We also having some experience. When a person is talking from afar, can we hear the louder one? No, we can't hear the louder sound actually. So if a person is talking with us from very near, then we can have the feel of loudness, more loudness. So which means what? More the distance, less the loudness, less the distance, more the loudness. Is it clear? Fine. So here loudness is inversely proportional to the square of the distance between source and listener. Source and listener. Fine. And here the third one is the density of air, children. Very important. Density of the medium. Density of the medium. Children, experimentally it has been proved that when density of the medium increases, loudness also increased. When density of the medium decreases, loudness also decreases. Clear? Fine, children. Now, the fourth one is surface area of vibrating body. Children, this is very important. Surface area of vibrating body. Children, first suppose, let us think about the two drums. One has the membrane will be there, which can be beaten so that what we sound is produced. So the drum with less, for just you think about the one drum whose membrane has less surface area, and one more drum you can think whose membrane has more surface area. So now you can think which drum can produce sound with more loudness. Obviously it's very clear that the drum whose membrane has more surface area will produce more loudness, which means what? If the surface area of the vibrating body increases, obviously what will happen? If the surface area of the vibrating body increases, then loudness of sound also increases. If the surface area of the vibrating body decreases, loudness also decreases. Clear? Fine. And here fifth one. What is the fifth one, children? Presence of resonant bodies. Presence of resonant bodies. Let us say n number of resonant bodies are there. Children, in a previous class which we discussed the resonance. At a resonance, what will happen, children? Loudness is increased. If two bodies are in a resonance, then what will happen? Its loudness increases obviously. So here if more number of resonant bodies are there, obviously loudness will be more. Means if the number of resonant bodies are increased, then obviously the loudness of sound also increases. Is it clear? Fine. So children, so these are the factors on which loudness of a sound depends. But here children, examination point of view, we will see how a question can be asked. One more question we will see. So that means based on the diagram children, diagram based also questions can be expected. Now we will see, so that you will get a complete idea about this loudness. Okay, now fine. Look at here. So two questions can be given like this. For suppose here. So let us do wave B. So like this, the questions like this, two diagrams will be given. So here two graphs will be given. They will ask you which of the following wave will have more loudness and why. Give a reason. They will ask you. First children, try to understand. So here only one wave is formed. Here one wave is mean the number of waves are same. So frequency is same. Frequency. As both will have same pattern, quality is same. But do you think that both will have same loudness? For that we have to see the amplitude. Let us say here amplitude is A1, this amplitude is A2. So obviously children, here amplitude of the second wave is greater than that of the first wave, and we know that more the amplitude and more the loudness. So here I can say the loudness of wave B is greater than loudness of wave A. What is the reason? Means you can say that wave B has more amplitude than that of the wave A. So like these questions also we can expect in exam. So children, this is about actually loudness and how it is related to the intensity, and the questions based on that. And one more important point we need to understand, what is that level of sound here. Some students are getting a doubt actually here. They have a confusion. So level of sound, children. So level of sound is expressed in terms of decibel. This is very decibel. So our normal conversation will be there, you know. So it will be up to 60 decibels. It's very important. This is a 60 decibel. Is it clear? So the unit of loudness is phone, PHON, phone. Am I clear? Fine. Whereas the unit of level of sound will be expressed in terms of decibel. Clear? Fine. Now we see the next two characteristics of sound, that is pitch. Fine, children. So what is a pitch, children, here? So pitch is a characteristics of sound by virtue a flat sound or the shrill sound can be distinguished from a flat note. So shrill note can be distinguished from a flat note. And this pitch, children, depends on frequency. Is a very important part examination. So pitch depends on frequency. Children, very important. Pitch depends on frequency. So more the frequency, more the pitch. Less the frequency, less the pitch. Clear? Fine. Now let us see how the question can be asked. So let us take one wave here. Here is wave B. Children, here the question can be asked like this. So like this, two diagrams will be given. They'll ask you which of the following wave has more pitch and give a reason. So first try to understand, children. What is the ratio of amplitudes here, children? Ratio of amplitudes. What is the amplitude? 5. Here also 5. So amplitude is same. As the amplitude is same, loudness will be same. So you can write. For example, if they will ask you the ratio of loudness, so this will be 1:1. Very important. Because amplitude is same, obviously the loudness will be same. Now which one will have more pitch, children? So we know that pitch depends on the frequency. First let us find out the which wave has more frequency. Children, what is the frequency? The number of waves produced in a second time, means more the number of waves, more the frequency. More the frequency means more pitch. Less the number of waves, less the frequency, less the pitch. Now out of these two graphs, children, here wave B has, means it has more number of waves are produced in the same time. More number of waves, so more pitch, more frequency. So obviously more pitch. So wave B has more pitch than that of the wave A. So we can write, so pitch of wave B is greater than that of the wave A. Since what is the reason? The frequency of wave B is greater than frequency of wave A. Is it clear, children? Hope it's very clear. Fine. And now the last characteristic of sound is what actually? Quality. So this quality of a sound only we also can call it as a timbre. Children, first suppose if two different musical instruments can produce sounds with the same loudness and the same pitch, then how they are distinguished, children? Yes, they are distinguished by a, what we can say, a characteristic of a sound, so called, what is that? Timbre or quality. Which means what, children? Two different musical instruments may produce two sounds with the same loudness and same pitch, but not with the same quality or same timbre. Is it clear? Fine. And here, children, this quality depends on which factor does it depend? Examination part of it is very important. So here quality of that depends on wave pattern or waveform. It depends on waveform or wave pattern. Now let us see one example, then you can understand very easily. Look at here. Let me take this wave A and here is wave B. Children, if you can look at here, which wave has more pitch? Further we need to check which wave has more, means in which case more number of waves are produced. So here only one wave is produced, here one wave is produced. So both will have same number of waves, that is same frequency, hence both will have same pitch. Then which one will have more loudness? If you can see, this is 5 centimeter. So here also 5 centimeter. Means what here? Amplitude is same. As amplitude is same, obviously what, children? Loudness is same. So in this case I can see that here the ratio of pitch will be 1:1, whereas even the ratio of loudness also 1:1. But children, Do you think that the wave pattern is same? No, wave pattern is not same. That's what I'm trying to tell you. So this is a sound wave produced by tuning fork. So tuning fork, whereas this is produced by piano. This is produced by piano. So that's what I'm telling you. Two different instruments can produce two sounds with the same loudness and same pitch, but not with the same quality, because they are differ in the quality. They are differ in the waveform or a wave pattern. Clear? Fine, children. So, and the last point in this unit, I can say in this chapter, is what? It is all about the differences between noise and what we can say music. Children, what is a common point between noise and what we can say music, children? Just you think. So children, here first point is that musical sounds are pleasant to hear, but whereas noise are unpleasant to hear. Children, whenever a teacher comes to your class, what they will tell? Do they say stop music or stop noise? Definitely they will tell that, dear children, kindly don't make a noise, or stop noise only they will tell, because which irritates, so which is a unpleasant actually. Fine, okay. And here this musical sound is produced in a regular manner, in a rhythmatic way it is produced, whereas noise is produced in a irregular manner. So it is irregular manner this noise is produced. And whereas here music has, so if you can see the waveform of the music, it has what we can say a regular pattern, particular pattern will be there. Here no pattern, it will be zigzag, it will be no pattern. So let me show you example. For suppose here means, for example, here it may have some like this. So particular pattern is there here. Whereas for this, if you can notice, this will be like this. It's like, in movies they'll be showing whenever there is a scene in ICSE, the heart beating, the pattern of the heartbeat they'll show like this. It's a irregular manner, it will be there. And your examination point of one important point is that children here. So musical sounds here, level of the sound will be 10 decibel to 30 decibel, 10 decibel to 30 decibel. But whereas for a noise, it is greater than 120 decibel. Children, when sound reaches 120 decibel only, we get irritated and frustrated, and it exceeds 120 decibel, it causes noise pollution, so which is very dangerous to the health. Clear, children? Fine. So these are the topics which we have in a unit C, children. So only one point. What is that point which we discussed? Characteristics of the sound. Under characteristics of the sound, which we discussed about the loudness, pitch, and the quality. Okay, children. So with this, we completed entire sound chapter. Am I clear? Fine. So children, my advice again I am telling you. So whenever you want to get a command on the content, so first you have to give priority for the textbook. So kindly read the textbook. Whenever you are reading the textbook, kindly keep a notebook with you, so that you can note down the important points, so that you have your own notes. And after reading the notes, children, just kindly go through the example questions. Many students are neglecting actually example theory questions, example numericals. So you have to solve that. After that only, just go through the exercise questions. Okay, children. So next, very soon we'll meet with one more new video. Okay, children. Thank you so much. All the very best.